Hey guys, Miss Pariseau here. We're going to talk about angle relationships today. So I'm going to start you off by taking a look at some images. Oh, let me adjust my camera. Uh, Maybe. Okay, there we go. All right. So just kind of going over some of the vocabulary. Taking a look at here is in one of our vocabulary we had that a line that intersects two or more lines is called a transversal. So this line that I'm highlighting in pink is a transversal because it's crossing two other lines. Okay, so from there we can then take a look at our different vocabulary, and we want to talk about inside the lines and outside the lines. So in this particular case, my exterior angles are 1, 2, 7, and 8 because they are outside of those two lines. All right, so imagine if you just draw that, that's kind of like your inside of the house, you're in between the two roads, so to speak. Okay, so that means 3, 4, 5, and 6 are my interior angles. So we have that alternate interior angles and alternate exterior. So an example of alternate exterior would be angle 1 and angle 8. By definition, alternate exterior angles means that they are on alternate sides of the transversal or opposite sides, and they are the exterior angles. So it can't be 1 and 7 because that's not opposite sides of the transversal. They're on the same side. All right. 1 and 8 would be an example of alternate exterior. 2 and 7 would be another example of alternate exterior. Then you have alternate interior. Well, just like the alternate exterior, they have to be on the opposite side of the transversal. So if I said, what is the alternate interior to angle 5? You would tell me angle 4. All right? And the same thing here, angle 3 and angle 6 would be alternate interior. All right, well, that's the vocabulary. But the way that we're applying it is now let's take a look at another image. Okay. So almost the same setup, but what are some things that you notice? What's different from this one compared to this one? Yep, line C is going in a different direction. We have lines A and B. But what does this symbol here mean? If you saw what I wrote up here, that means A is parallel to B. So it's saying that line A is parallel to B. Whereas up here, I don't have any marks. And we can see that if I were to extend these, they would eventually cross. All right, so we're going to take a look at the same type of relationships that we saw in this example, okay, in this one. So here again is our transversal. And if I wanted to take a look at alternate exterior, so let's take a look at the same ones. 1 and 8 are still alternate and exterior angles. They're on the outside and opposite sides of the transversal, okay? So now I'm going to lay this plastic over just to kind of show you. When we have parallel lines, interesting relationships occur. So if I go ahead and trace angle 1 with that marker there in blue, okay? Now, if I rotate that, okay, I can see no matter which way I line it up, it's not the same as angle 2, okay? But if I rotate it again, I'll notice that it's the same as angle 4. Remember, angle 1 and angle 4, they share a vertex. They make that V. They are vertical angles, and we can see that they are equal in value. Well, let's slide that over, and we traced angle 1. I'm going to slide that over, and what do you notice about angle 8 and angle 1? They're equal. They're equal in value. So if you have parallel lines, alternate exterior angles are going to be equal in value. And to prove that, I can also show you for angle 2. So if I were to trace angle 2, all right, notice it would also equal angle 3. And then if I slide it down, it would also equal angle 7. And angle 2 and angle 7 are alternate exterior angles. So conclusion, alternate exterior angles are congruent when you have parallel lines. Because if they are not parallel, all right, if I were to trace this, now, okay, tracing angle 1, and I try to line it up on angle 8, notice it's slightly off, even if I try and line it up, and I know I didn't draw it very straight when I traced it, but it's slightly off. So the lines have to be parallel in order for you to say that the alternate exterior angles are congruent. All right. Now let's take a look, going back to that comparison of looking at alternate interior. So we'll take a look at angle 4 and angle 5. Okay. So again, if I go and take a look at my ones with the parallel lines, I'm going to do the same experiment here, and I'm going to trace angle 4. There's angle 4. If I move it around, we already saw that it equals angle 1 because it's vertical. If I slide it down, we see it also equals angle 8. Well, that makes sense because if it equals angle 1 and angle 1 equals angle 8, that works. Okay, but then if I turn it around, okay, we can see that it also fits angle 5. So alternate interior angles, when the lines are parallel, are equal in value. Okay. Now I also just made another connection. Look at angle 5. If I slide that up, it matches angle 1. They are on the same side of the transversal. That is called corresponding. They are corresponding angles. So angle 1 and angle 5 are corresponding. Angle 3 would correspond with, that's right, angle 7. What about on the other side? What would correspond to angle 8? Angle 8 would correspond to angle 4. They are the same angle, just in different locations. So they're on the same side of the transversal, but shifted downwards. And notice when I was moving this around, corresponding angles were equal in value as well. Okay, so our conclusions, all right, if we're going to come to some conclusions here, let me get a plain card. So when we had the parallel lines, okay, this was the key. They had to be parallel lines cut by a transversal. Alternate exterior angles were congruent. That's the symbol for congruent. So if I know one, I can figure out the other. Alternate interior angles were also congruent. Then we saw corresponding angles. So like 4 and 8. Well, corresponding angles, they also were congruent to each other. Right? So those are our special names. Now, there's also another relationship here, and we could figure that out. Look at that relationship between 4 and 6. Well, 4 is the same as 8. So let's just say that angle 4 was, I don't know, that looks about, it's a little less than 90. Maybe it's about 70. We'll use 70. So if angle 4 is 70, that means this is 70. So what is, if angle 5 is 70, we can use what we know about linear pairs. 5 and 6 would make 180, so that's 110. So 4 and 6 are supplementary. These are what are called consecutive interior angles. And that's abbreviation, but on your vocab sheet you have it spelled out. Consecutive interior angles, they add up to 180 degrees. So understanding these relationships in parallel lines can help us solve and find missing angles algebraically.